All right, so I just wanted to make a quick video here, really on a synthesis problem that kind of ties a lot of things together and just kind of explain what's happening here. So we have this, with this ethyl benzylic guy here, and we're trying to basically just add a cyanide to the end. So we're adding a carbon and we're adding a nitrogen. So we're adding two things, and through sodium cyanide, which ionizes to this, we can add it in one step, which we see here. But how do we get there? It's kind of complicated to get to that point. Obviously, we can't just stick this together because we have a nucleophile here, and we just have a carbon attached to a benzyl ring. All right, so the first thing we're going to do is, because this generally is unreactive, we need to use a radical. And your kind of garden variety, first thing that we remembered is that if we add Br2 and heat or light, we're going to add bromine. I think you could also technically use NBS here because this is an allylic carbon. We're going to add a bromine to that. It's also, I guess, technically a secondary carbon, because it's attached to two other carbons, so it's going to be the more stable location. So now we have a leaving group, and we can eliminate this using a base. I don't know if OH minus would work here. Tert-butoxy is usually a good bet. There's a bulky base. It's going to eliminate and give us this, which we can see here. So now we have a nucleophile to work with, and if we're trying to, getting a bromine on the end of this would be great. So to get an anti-Markovnikov bromine, which would be here, we would add HBr in the presence of a peroxide, which would give us an anti-Markovnikov, break our double bond here, which is exactly what we get. And what happens here is that this bromine has a partial negative charge, giving this carbon here a partial positive charge. In other words, making this an electrophile. And you remember that we have a nucleophile here, so that's perfect. This can come, do a backside attack. The bromine is going to leave, and we're going to get this as our final product. What's interesting is that what you can also do is, if you have a benzene ring and you have this same product, CH2 bromine, you can reverse the charge here. If you added like an Mg, and I think it's THF, what you would do is that you would slide a magnesium here, and a magnesium is very electropositive, which would now, because it has a electronegative number of 1.2 compared to carbon's 2.5, so by contrast it's going to give carbon a partial negative charge, thus making it a nucleophile. So now that it's a nucleophile, you can react it with an electrophile, like an H+, which I think would just make it a methyl, a ketone, which because of electronegative oxygen puts a positive charge on carbon, so you could attach a ketone here. Or an interesting option would be an epoxide with two carbons here. Again, the electronegative oxygen is going to put a partial positive charge on both of these carbons here. So that's what we can kind of add here. Those are electrophiles. Also, an alkyl halide could come in also, which I know is kind of counterintuitive, but an alkyl halide with a partial positive charge, which is kind of like what we started with, could come in too, and you could extend your carbon chain if you wanted to. The other thing you can add to this, which I think is this over, or it's like lithium over CuI, which would turn this, which would turn this, just like a glitch in the matrix here, anyway, it would turn this into an organocuprate. You would still have your CH2, and you'd still have your CH3 in this case. But it would take off that bromine, give this 2. This would be a Cooley. Copper is a Gilman reagent. They have 8 gills, so this is a 1.8 compared to 2.5. Again, making this electronegative as a nucleophile, and then you'd be able to come in and add. You could add this, and you could add 4 carbons to your chain, which would start right here. So all these different options of what you can do with synthesis here. So just to really dive it home, your initial thing that you can do here, and you could also, if this was this, or I guess this would be a better example. This is an allylic carbon, this is an allylic carbon, this is an allylic carbon. So if you're adding like an NBS or like a Br2 in heat or light, those are all potential options where you would add a bromine to. Then you'd have a leaving group nucleophile here, which you could come in and do some type of nucleophilic attack and go from there. All right.